Okay, so we get started on class 10. Believe it or not, we're 5 weeks into the semester and we're on chapter 8. So we should be on schedule to finish up our quick introduction to Python and then get into writing some scripts after spring break. What I'd like you to do is bring up PyCharm and then click on the File menu and go down to Settings. I'm going to show you how to create a pre-programmed header for your scripts that you write. And when you do that, it's going to open up the different setting options that we have, and you want to open up Editor and then go down to the File and Code templates. And then once you've done that, if you look over on the right-hand part of the screen, these are the different templates that are built into PyCharm. And if you'll notice, the one that we've been using up to this point is a template called File. And it's not listed there because you can't mess with it. So in this case, what I'd like you to do is click on Python script. Do a left click on that. And then if you go immediately above that, next to the minus sign, you'll see an icon that will allow you to copy that template. So go ahead and copy that template. And when you do, at the bottom of those templates available will be a copy of Python script. Now, you can right-click until the next ice storm, but you're not going to be able to change the name of copy Python script. We do that over a little further over on the right side where it says name. So I put something really creative in mine, like Python header script, whatever you want to use. And you'll notice that currently is a double underbar author and another double underbar, and then the code to bring up the username on the computer. And we'll get into these codes a little bit later in the book. But for right now, that's the username. Well, I've gone through and I modified mine. And so I set it up like this. I put a number sign in my name and project. And then to automatically fill in the date, I've done a double underbar date, double underbar equals, and then you put in single quote marks, $, and date in capitals. And then underneath that, I've put in the normal areas of a script that I'm going to create, or I kind of like to separate out. All right, the next step is to go down and click Apply. And once you do that, you'll notice that the header changes over to Python header script or whatever you decided to name that. And then the final option is click OK. Now this will be out on the website, so if you didn't get quite through with all of it, you can go out and modify it and do anything you want to. So the options it adds for us, now when you right click on your project, you'll notice that along with all the other options, we now have Python header script. That's what I have. And if you click on that, it automatically creates a Python file for us. You can see section 82.python. So the program knows right away it's a Python file, and it's filled in all of the pre-program information we want to fill in. When we finished last week, we had started to take a look at the function structures in Python. And if you'll remember, we can or cannot have arguments. It depends on what your function is going to do. And functions always begin with the keyword def. And then we define what's going on. Variable scope. Variables not declared in a function are not related to any, or the variables declared in a function aren't related to any variables outside a function for now. That's going to change a little bit. When you name your variables, yes, you could name a variable inside a function and use that same name in the remainder of your program, and it wouldn't cause any problems. But you don't want to push your luck, because we're going to see here in just a couple of slides where we can declare what's known as global variables, and then we could start to have some problems. So you'll see how that works. But in a normal circumstance, what you declare in the function isn't related to any variables outside the function. We'll look at that a little closer. Now, if you want to type along, go ahead and type along. But this is what we're looking at for local variables. We're going to go ahead and create a function, and it's going to print our x. We've got a value of x set up, and then we're going to go into the local variables and create that x. And we print it out using our function. The local variable is 50. We change the variable in the function. We can see it's changed to 2, but when we print it out again, it's still 50. So what we are declaring as our local variables in the actual script isn't being affected right now by our function. So you can do anything you want to with those variables, and it's not going to be affected. The actions that occur on the variable only occur in the function. All right, so this one's pretty simple. It gives you a rough idea of what's going to happen. Couple of tips on local variables, on functions as we talk about local variables. Sometimes you might want to write a function, or you might be outlining your code, and you don't want to write all the code that's going to go under the function. So you can use a keyword called pass. And that pass statement just does absolutely nothing. It's a null value. If we would change a piece of code that we wrote last week and put in print minimum and pass, and then run that function, absolutely nothing's going to happen. So that's one of the things that you can use. Now, it's kind of a nice thing if you're trying to outline your code and put it in, or maybe create some pseudocode and work with it. A lot of times when you're doing a large development, you may do a code outline on different blocks that are going to happen, and you know there's going to be a block called print min, but right now you're not ready to write the code for it. So you can use the pass variable, and it'll save you some time and space, and then you can work on it as you need to. We talked about local variables in 8.2. Now we're going to talk about global statements. And we can create variables, global variables in a function, and we've got to identify them to Python so it knows. The key word, obviously, global. And once we've declared a variable is global, we can use it anywhere in our script. We can use it in functions. We can use it in the main body of our code. Our book is bad about this because it'll declare x as a variable in a function, and then it'll go down and declare x as a variable in our main line of code. And as long as you're not declaring a global variable, that's all right. But I'd recommend you get out of the habit of doing that. First of all, I recommend you describe your variables as much as you can on what the values actually are. And then secondly, once you get out of that habit of using X all the time, or A all the time, or B all the time, your code's going to become a whole lot more understandable. Now, in the code that we're writing, I think the biggest one we've written so far is 24 lines of code. All right, you can pretty much look at your code and see where x is a function value and x is a main loop value. But if we start to get into scripts where we're writing 100, 200, 300 lines of code, you may not be able to look at it and simply remember where this x is originally declared, and is it being used as a global variable, or is it being used in another loop or another function. So I'd recommend you name your variables, make them descriptive. All right, so global variables, we can use them anywhere. We make the name unique. This is going to be a fun tape to edit. All right, here we are looking at the global variable. So, and this is where I wish the textbook wouldn't do it, but I kept the example the same as the textbook. We're defining the function, and notice at line 7 we create a global x. So that global x can be used anywhere in our function. So we come down and we run the function and we say print x equals 2. We change the global x to 2. All right. So we run down, take a look at the local variable. We're also setting x up again t equal 50. So now we print the function. We run the function and x is 50. All right. And we print the value of, and that changes the value of x to 2. We come back down to the end of the program and it stays the value of 2. All right. This would have been much better had they changed line 13, but they didn't. Global value, once it's activated, is going to be consistent throughout the rest of your program unless it's acted upon again. This program actually ran. We start at line 12. And we say x equals 50, and then we call the function at line 16, and that's when we change it. So notice we're printing out x, printing out the x value, and then we modify it after we've declared it as a global value to 2. The key here to remember is this global x isn't activated until you run the function. Two things that you need to take out of 8.3. First of all, your function doesn't do anything in your code until you call it. And then if it has a global variable in it, it's going to change the value. Now we get into default arguments, and this is going to muddy the water maybe a little bit more. Default argument values are values we're going to put in for two reasons. First of all, if the end user doesn't want to record a value, there will be a default value there for the function to operate with. And we use the equal sign to determine what that default value is. If the end user puts a value in for that argument, then the end user's value is going to override what we've declared in the program. So if you don't provide a value, that default value is going to be there. If we look at this code, what we're doing under the function definition is we're putting in a message, and then we're indicating the number of times we want that message to print. So if you look at it at line 11, we're saying send to our function the word hello. And so since we have not indicated a value for times, the times value remains at 1. And if you look at the second line under our run portion of the screen, you'll know it said hello. Notice it says hello 1 time. Line 13, we go ahead and change the times with a user-determined value. So now it's going to say world 5 times. default argument we can set up to be any value that we want to, and we can set it up with one limitation on any argument within a function that we want to create it for. There's something here though that you need to look at a little closer. Does anybody see what it is? Let me blow that up a little bit. Take a look at this. What are we doing in line 7? And what's message? Message is a string. So we're multiplying a string times a number. Does not compute. You do this in C#, and the program will probably say, sorry, you're not old enough to use this program, and shut down. What Python is smart enough to do is say, oh, you've got a print statement, you've given me a string, and you've given me a number. You must want me to print that statement X number of times. Kind of a different way to think about programming code. And that's what makes Python a little unusual in scripting. Here's the gotcha on this one. Only the parameters at the end of the parameter list can have that default argument value. I could give message and times a default value. That would be okay. Or I can give times a default value. All right, but it has to be at the end after what is being prompted for the end user to put in. All right, 8.5, we're going to see that. We're looking at 8.5 at keyword arguments. If you think about it, there may be instances where you only want some of your parameters to have predetermined values. So that's known as a keyword argument. All right, advantages. You don't need to worry about the order that the arguments come in. We're going to actually name the arguments. So values are determined, the function knows how to handle it. And again, we may only at certain times want to use certain values within that function. This section of the book you really need to get a handle on, but I think the only way you're going to do it is to go through and enter the code and work with it and play with the lines and make changes to see what happens when you make changes on these. I think that's going to help you out. So if we look at what they've got set up for us in 8.5, notice that we've got function again. Our function, they use func, func, and A, B, and C as our parameters. What is A? Don't say a number. What is A? What do we know about A looking at it at line 6? It's a parameter. Okay, we know it's a parameter. What else do we know about it? Does it have a default value? No. All right, so what does that tell us? It's going to have a user input. Very good. Is that input a number or a character string? Right now we don't know. Yeah, it's not defined. It could be either one from what we saw in section 4. Okay? Now, B equals 5, C equals 10. What's that tell us? Their default values are, if the end user doesn't put anything else in, doesn't change B and C, then that's the numeric values that the function will operate under. Could I have said A equals 10, B equals 5, and leave C to be user determined? Why can't I have C be a user input that has no value? All of the default values have to be at the end of the parameter statement after the user input value. All right, so A is requiring a user input, so only B and C can have pre-assigned values. What if I added, or D after C? Would I have to give it a pre-assigned value? So you can take a look at what we're doing now in lines 11, 12, and 13. The first thing we're doing is entering a 3 and a 7. don't look at the code down at the bottom. What parameters in our function are those numbers assigned to? A and B, okay. And in line 11, what parameter does 3 go against? A. And 7 goes against B, and C remains 10. All right, let's look at line 12. Now, will line 13 give us an error? All right, tell me why line 13 is not going to give us an error. So as long as we identify the parameter in the function that we're defining, we can define them in any order that we want to define them. Even though A, we know, requires some sort of user input, as long as we identify A and C in this case, we can put A at the end. Okay, to take us a step further, and this is the last part we're going to do today, is we can have variable parameters within a function that we create, which means that a variable may not even be necessary unless a value is assigned to it. And we do that by using the wildcard symbol or the asterisk. So each group that's declared as an asterisk is a collection of values or a tuple, and we'll find out more about that later. So we use that asterisk and we can create collections of it, or we don't even have to use the value that's assigned. It's totally up to the needs of the program at the time that it's run. 8.6 sets this up this way, and this again is another one of those pieces of code that you really have to look at to get a feel for. So the function, okay, that's big enough. So the function total has initial as a value equal 5, and then numbers has a single asterisk, which means I don't have to have any numbers at all if I don't want to, and the function will totally ignore it if it's not there. And I've got another double asterisk for keywords. If I don't have keywords in there, I don't have to worry about it. My function is totally going to ignore it and not process it. So what we do down in line 16 is we tell it to print total. And so for initial, even though that has a current value of 5, we're going to assign 4 different numbers to it. 10, 1, 2, and 3. All right, so that's looked at as a tuple, or you might think of it as being looked at as a single line array. All right, and it's going to take those numbers in line 8, and it's going to perform a function on them. For our second variable, numbers, we wouldn't have to have anything there at all if we didn't want to. But in this case, we're saying vegetables equals 50. All right? And then the same for fruits. We wouldn't need a keyword, but we could put it in. So you can see the way they controlled it. They must be getting paid by the line on this one. They are writing a for statement for each one of those different parameters in the function. The count equals initial for numbers, and then for key, and then whoever asked the question. There we are returning the count. And Thursday when we get together, we'll take a look at that return and see what it does for us. But when you run this program, notice what the answer is down on the run section, 166. So we got to think about what happened here. It added them up, right? All right, and then for numbers in numbers, what did it do? It took the count and it said add whatever numbers are in numbers to the count that we have already. And then the last statement is almost the same. We're saying for the keywords, the first one, let's add in that value also. So if you add everything up, You end up with 166. What would happen if we ran just print total with no values assigned to it? It'd return 5 because that's an assigned value, whether or not our end user makes a change or not. Okay, next class we're going to take a look at the return statement and we're going to take a look at document strings.